right, so to recap what we just talked about, if you want to multiply two complex numbers that are in trig form, you're going to multiply the r's and add the thetas. If you want to divide two complex numbers in trig form, you're going to divide the r's and subtract the thetas. Okay, and that's what this tells you down here. You're multiplying the moduli r and adding the arguments theta. I don't use those words because they're weird. All right, so let's do some examples of this. So we want to find the product of z1 and z2. So the first thing we're going to do is multiply the r's, so 3 times 2. And then we are going to add our angles, theta. So it'll be cosine of pi over 4 plus 3 pi over 4 plus I sine pi over 4 plus 3 pi over 4. So that's going to give us 6. Pi over 4 plus 3 pi over 4 is just pi. And that's it. We can evaluate this. We're not quite done yet because those are great numbers. Now, if you were asked to leave this in trig form, this would be your answer, but we can actually go a little bit further with this. So the cosine of pi, so if you think about your unit circle, we're over here. Cosine of pi is -1. Sine of pi is 0. And I'm running out of space. Obviously, that's just 0. So our final answer is -6. That's kind of fun. Let's try another one of those. We want to find the product of these two numbers. So z1 times z2. So we're going to start by multiplying our r's, 2 times 8. And then we're going to add the thetas. So cosine of 2 pi over 3 plus 11 pi over 6. And then I sine, same thing, 2 pi over 3 plus 11 pi over 6. So we get 16. Let's see, probably want some common denominators, so I'm going to multiply top and bottom by 2. So that's going to give me 15 pi over 6. Does that sound right? I think so. So 15 pi over 6 plus I sine 15 pi over 6. Oh, that's reducible. You can reduce that. Let's do that. So 16, let's see, that gives us 5 pi over 3. Okay, if we were asked to leave your answer in trig form, you would stop there, but I think on the homework they want you to go a little bit further. So we're actually need to evaluate cosine of 5 pi over 3. So 5 pi over 3, that's in the 4th quadrant. So that's our 60-degree angle, 1, 2, root 3. Except, of course, this is negative. So the cosine of 5 pi over 3 is going to be 1/2. And the sine of 5 pi over 3 is negative root 3 over 2. And then our last step is to distribute that 16. So we get 8 minus 8 root 3 I. Okay, so again, this is your answer in trig form. This is your answer in standard form. So it just depends on what you're being asked for. All right, let's check out some division properties here. If you want to do division, instead of multiplying the r's, you're going to divide the r's. Instead of adding, you subtract. Also, we can do these in degrees. Everything we've done so far is in radians, but degrees works exactly the same. So if we want to find z1 divided by z2, we're going to take 24 divided by 8, and then cosine 300 minus 75. And same thing for sine. So we get 3 cosine of 225 plus I sine of 225. Okay, this is your answer in trig form. I think we want our answer in standard form today, so we need to evaluate this. So we have 3, 225 is over here in the fourth or the third quadrant. It's a reference angle of 45 degrees. Those are both negative. So the cosine is going to be negative root 2 over 2. And the sine is also going to be negative root 2 over 2. And then when we distribute that 3, we get negative 3 root 2 over 2 minus 3 root 2 over 2 I. And then this is your answer in standard form. All right, one last one. We want to find the quotient of Z1 and Z2. So we are going to take our R's. Oh, these both have an R of 1, just 1 over 1. And then we have cosine of 40 minus 10 plus I. Oh, I didn't mean to do that. Of sine, I times the sine of 40 minus 10. So that gives us cosine of 30 plus I sine 30. Again, this is your answer if you're stopping in trig form. If you want to put it in standard form, we go ahead and evaluate this. The cosine of 30 is root 3 over 2. And the sine of 30 is 1/2. So root 3 over 2 plus 1/2 I. In the next video, we'll talk about how to raise a complex number to a power.